Good day and welcome. Thank you for joining this presentation. This is part of the IEEE 12 Control System Research Curriculum. So our paper for today is Effect of Graph Matrix to Detect Anomalies and Non-Anomalies on Facebook using machine learning models. My name is Rabab and I'm presenting on behalf of the authors team. Thank you for joining our presentation. So today our paper is about online social network and applying graphic representation and then machine learning techniques into detecting anomalies and anomalies. So this is a sample of the previous related work previous to our work. This work is actually part of a continuous work as a part of a PhD study that was performed by one of the authors. So we have here a short review of the most relevant literature that is relevant to our work. So the table shows the authors, the year, the method that was used, and of course type of work, type of anomalies, and also type of data which actually represent whether this is supervised or non-supervised machine learning. Now also we have a list of the data set that has been used. Having said that, we move directly to our methodology. So our methodology is relatively straightforward. And before we start with the methodology, there is the data collection, which is basically the first step, then followed by the methodological steps, which are three. First one is the data pre-processing, then followed by anomaly detection, machine learning classifiers, and followed by the performance evaluation matrices. So first of all, we start with data pre-processing. So first we start by modeling the graph, of course, because we said that our data will be following a graph modeling, and then we segment the graph, and finally we extract the features. So once we have extracted the features, and then the data will be labeled at that point, then we will start with the anomaly detection using the classifiers. During that process, actually we're using three classifiers at the same time. These classifiers are the SVM, support vector machine, logistic regression, and multi-layer perceptron neural networks. Okay, so shortly neural network. So after we're done with anomaly detection with all the three classifiers, then we move to the last phase of our methodology, which is evaluating the performance. So the matrices for evaluation to measure the effectiveness of the classifiers through, of course, the matrices of the performance. So these are the three, which is precision, sensitivity, and F1 score. So as you can see from the table, we have true positive, false positive, and then false negative and true negative to represent our finding. So precision is true positive over true positive plus false positive, and then sensitivity is measured by true positive over true positive plus false negative, while F1 score is precision times sensitivity over precision plus sensitivity. So these are the measures we're taking. Okay, so what are the experiments that we did? Simply, we want to detect anomalies and non-anomalies through the three features that we have discussed previously. So we want to measure anomalies and non-anomalies that are extracted from Facebook. So we measured betweenness, closeness, 30, and Asian vector, also cluster coefficient using the classifiers. Okay, for all the three classifiers, performance of course was measured using the matrix, in terms of sensitivity, precision, and F1 score. And then that was done using the coefficient matrix to determine the performance of the 3 classifiers. Okay, so I think the results are quite self-explanatory with the details of the 3 different classifiers. So the blue, of course, is the LR, and the SVM is the maroon red, and then the green is the neural networks. So it's quite clear for betweenness and clustering agent, and then closeness for all the 4 items we're looking for, and then the results are displayed in the part below. So the results were also compared with previous result that is shown in the table, which is table 3, just beside on this side of the slide, and the top shows, of course, the previous work, and then the lower part, which is the SVM, LR, and neural network, shows the results. And I think it's quite obvious with clarity the difference in results. Now, finally, we conclude that, of course, the precision is higher in SVM and R. And then, of course, with the different technologies, there are different findings, which reaches its highest most with the SVM achieving excellent results to the high sensitivity in detecting anomalies, which reached about 98%, which is, of course, the top finding of this research. Now, the conclusion is that this paper present the use of graphic matrix to predict anomalies and anomalies in Facebook data, emphasizing on the importance of machine learning method using classifiers that has been mentioned before to detect anomalies and anomalies. So the highest findings were with the SVM with 95% F score in classification, and 98 in precision, indicating that the SVM is suitable for identifying non-anomalies and anomalies. 91% sensitivity, suitable for detecting anomalies and anomalies, of course. The future of this research will be focusing on extracting more features to use more machine learning methods and classifiers, finding new ways to extract feature and then enhance the precisions of the classifiers. This is a sample of the references, and thank you very much.